common collector configuration, biasing for NPN transistor and PNP transistor. First, we learn common collector configuration. In common collector configuration, collector is common terminal. This is a BJT. This is a NPN transistor. Arrow is outside. Then NPN transistor. This is collector. This is emitter. This is base. Collector is common for input and output. So, collector is a common terminal for the input port as well as the output port. So, in common collector, base is the input terminal, emitter is the output terminal. So, this is the input, this is the output. This is input port is base collector is the input port, emitter collector is the output port. The second letter C indicates the common configuration. Here C is the collector, collector is common. So in collector, common collector configuration, input port is a base collector junction, output port is a emitter collector junction. Emitter is output, so that the other name of common collector amplifier is called it as emitter follower. Emitter follower. So the other name of common collector amplifier is called it as emitter follower. So this is a configuration arrangement. Base collector input, emitter collector is output. This is NPN transistor. So the NPN layer, NPN transistor layer is, emitter is N-type semiconductor, base is P-type semiconductor, collector is N-type semiconductor. So this one is emitter, this is base, this is collector. So input is a forward bias. Base is P-type semiconductor, so base terminal gets positive supply with respect to the collector. So base positive, collector negative, input port is in forward bias. Output is reverse bias. Emitter is N terminal, so emitter gets positive with respect to collector. So emitter is positive, collector is negative, so output is reverse bias. Okay, I repeat again. In order to make this common collector configuration as the amplifier, input should be forward bias, output should be reverse bias. Input terminal is base terminal. In the layer diagram, base is a P-type semiconductor. For the P-type semiconductor, if you are giving positive DC voltage, then it will be the forward bias. Positive DC voltage with respect to collector. So base is positive, collector is negative, then input base collector junction will be in the forward bias. Output terminal is emitter. In the layer diagram, emitter is a N layer. So output should be reverse bias. N gets positive DC supply, then it is reverse bias. So emitter positive, collector negative, then the output emitter collector junction will be the reverse bias. This is biasing arrangement for common collector configuration for the NPN transistor. Let me see about the PNP transistor. In PNP transistor, PNP in the layer diagram, emitter is a P-type semiconductor, emitter layer is a P-type semiconductor, base layer is a N-type semiconductor, collector is the P-type semiconductor. In P, arrow should be inside. Okay, so this is collector, this is base, this is emitter. So here the collector is common for input port as well as the output port. So input port is base collector junction, output port is emitter collector junction. This is the output port. Okay. So input forward bias, output reverse bias. So P layer is N-type semiconductor, so it gets negative DC voltage in order to get the forward bias with respect to collector. So base negative, collector positive, though input base collector junction is in the forward bias. In the output side, emitter is a P-type semiconductor. So P gets negative, then collector gets positive. Emitter gets negative, collector gets positive DC supply, then output emitter collector junction will be in the reverse bias. This is the biasing arrangement for common collector PNP transistor, PNP transistor. Okay. Thanks for watching.